Hello there. Welcome to College Algebra. You're about to embark on quite the adventure through many algebra concepts that will help prepare you for either your major or whatever it is that needs college algebra, or if you're going on to trigonometry and pre-calculus, definitely prepare you for those classes. So let's just jump right in and start having some fun here, starting in chapter 1. Uh, just doing a few concepts from chapter 1 in 1.1, dealing with real numbers in the rectangular coordinate system. At first, you're going to find that we kind of just hit a few things and skip some stuff, just trying to make sure you've got a few concepts down to help with later problems. Speaking of which, in 1.1, we're diving into the Pythagorean theorem. I think most of you have heard of this before, even if you don't recall it, and you might kind of recognize it as we go if you don't already know what it is. The Pythagorean theorem, it provides us a formula for finding the length of the third side of a right triangle when the lengths of two sides are provided. So if you have a right triangle, a triangle with a right angle, as long as you know two sides, you can find the length of the missing third side. And the formula, we've got right triangle here with the right angle. The sides attached to the right angle are your legs, A and B. The side opposite the right angle is your hypotenuse, C. And the formula for figuring out, one of the sides, if you know two, it would be side A, the length of side A squared plus the length of side B squared has to equal the length of the hypotenuse squared. And this is really a simplified form of the law of cosines for those of you who have a trigonometry background. The law of cosines looks a lot longer than this, but if you take a triangle with a right angle, 90-degree angle, and put it in for the theta in the law of cosines, that cosine of 90 goes away because you end up with that 0, and it simplifies down to a squared plus b squared equals c squared. So that's really what you've got here. And then the C is the longest side. It's opposite the largest angle. That's true with triangles. The largest angle has the longest side opposite. Smallest angle has the smallest side opposite. Middle angle would have the middle side opposite. So that's what we got here. So let us go ahead and do two problems with this. I'm going to go ahead and choose black. Okay, let's go ahead and do two problems. One of them, you're going to have sides A and B and find C. The other, you're going to have a leg and the hypotenuse and then have to find the other leg. So let's start out with this one. If you look in your book carefully, you'll often see that I'm just picking problems right out of the book, usually even numbers. In this case, I'm on page 10 in our current textbook using number 78. But we've got a triangle with a side A of 7, a side B of 24, and you're trying to find C. Okay, so you've got a right triangle you're dealing with here. Side A is the 7 units, side B is the 24 units, and side C is the unknown. Well, since we are dealing with the right triangle, we can say we know that a squared plus b squared equals c squared. So a is 7, so 7 squared. B is 24, so 24 squared equals c squared. I know 7 squared is 49. 24 squared, 24 times 24, work that out, and you get 576 equals c squared. And 49 plus 576 will give you 625. And you're not done. People like to try to stop here and say, hey, the answer is 625, but it really isn't, because 625 equals c squared. And you want to figure out what c equals. Well, to solve this little equation here, 625 equals c squared, you could take the square roots of both sides, keeping in mind there's two square roots. So you got plus or minus square root of 625. But then you might think real quickly and go, wait a minute, we're dealing with the length of a side of a triangle here. We don't need the negative answer, because when we're talking about the lengths, we're going to just deal with positive numbers. So we can just focus on the positive square root of 625 and see what that comes out to. Well, in the case of the positive square root of 625, it comes out nice and evenly to 25. If it had not come out nice and evenly, you would go ahead and simplify the square root, but leave it in the square root or exact form, unless otherwise stated. If it states, round to the nearest tenth or something like that, then you can say, well, I'm putting it in my calculator, round, but otherwise, you just keep it in exact form. Okay, so side C is 25 units, and that makes sense because your sides A and B are shorter than side C. Even though B is not that much shorter, it still is shorter, so that makes a lot of sense. Okay. Let's try a second one. It's real common to be given the legs, A and B, and have to find C. But what if you're given a leg and the hypotenuse, and you need to find your one of your missing leg? All right. So let's say we have a triangle where we know side A is 14, and we know side C is 50 units, whatever the units are, inches, feet, whatever. And we're trying to find B this time. Okay, so in this one, I'm going to sketch a triangle here. I don't know how this is going to work out exactly, but I've got side A is 14 units, side B is my mystery side, and side C, or the hypotenuse, is 50 units. Okay, so again, dealing with the right triangle, no two sides, trying to find the third. A squared plus B squared equals C squared. So I've got 14 squared plus, this time B is my unknown, so I have to keep that as B. I can't plug in 50 there because 50 is the hypotenuse. 50 gets to go over to C. Okay, so I got 14 squared is 196 plus B squared equals 50 squared, 25 with 2 zeros. All right, subtract 196 from both sides. I get B squared equals 2304. And honestly, I am not going to know that square root off the top of my head, so I'm not showing it, but I'm going ahead and punching that into my calculator and figuring out what the square root of 2,304 is. And it ends up being 48. So side B in here is 48 units. And that makes sense too, because 14 and 48 are less than 50. All right. So that Pythagorean theorem, just a little bit about it. I think you probably could guess, if you didn't know already, that it was named for a guy that sounded like Pythagorean. In this case, it's Pythagoras, Greek mathematician who lived 580 to 500 BC, so a long time ago. He's got the credit for discovering it, but for a long time we thought he had. But then as scholars, keep unearthing more information, we find out otherwise. For one, during Pythagoras' time, he was the head of a secret school of scholars called the Pythagoreans. And chances are he didn't come up with it even then. Probably when some of his students came up with it. And so, since he was the head of the school, his name gets attached to it. His Pythagoreans came up with it, so Pythagorean theorem. But then, in recent times, archaeologists are shedding even more light on the fact that they weren't even the first to come up with it. Turns out Babylonians were using it between 1900 and 1600 BC, long before Pythagoras even existed. They had unearthed the Babylonian clay tablet Plimpton 322. It's a pretty famous tablet, and it had to be deciphered, and they deciphered it, starting 1945, and we're discovering, hey, right here, this is some mathematics on this tablet, and it has the Pythagorean theorem. And then just another little side note, back then it wasn't just the Greeks, also the Egyptians were using it. They used it around 300 BC, but we didn't know about them using it around that time until the Cairo mathematical papyrus let us into her secrets. That was unearthed in 1938, but not fully examined and understood until 1962. So just a little math history there for you about the Pythagorean theorem. Now, the Pythagorean theorem can be used to also derive other formulas, including the distance formula. If you have 2 points on a plane, on a flat surface, and you want to figure out how far apart they are, you can use the distance formula to help you to do that. You can derive that using the Pythagorean theorem. Okay, so the Pythagorean formula, move that down a little bit so you can see. Pythagorean formula, if you have 2 points, like one point we'll just call generic x1, y1, another point we'll call generic x2, y2. You want to find the distance between them. You can sketch a right triangle here. You can say, well, I can look at that horizontal distance as the distance between the x values, and I can look at that vertical distance as the distance between the y values, and the horizontal and vertical together make a right angle. And all three make a nice right triangle. So you can look at the horizontal distance, the difference between x's, as one of your legs, and then the vertical distance, difference between your y's, as another leg. And you can put the horizontal, the x2 minus x1 in for A, the y2 minus y1 in for B, because those are legs. Then instead of calling the hypotenuse C, we'll just call it D for distance. Put all that information in and solve for D. Say D equals, and then positive square root, since we're dealing with distance, positive square root of x2 minus x1 squared plus y2 minus y1 squared. And then you can use that formula to help you to find the distance between 2 points. So let's do that. All right. Let's say you have a point P that's at coordinates -3, 4. And let's say you have a point Q that's at coordinates 2, -1. If you really want to, you can plot them on a grid. -3, 4 right here for point P, and then 2, -1 right here for Q. And you're trying to figure out, how far apart are they? All right, so distance formula. Just pick one of the points to be your x1, y1. Pick the other point to be your x2, y2. Doesn't matter which one's which. Just be consistent once you pick. All right, so then finding the distance, we've got x2, which is 2, minus x1, which is -3, quantity squared, plus we got y2, which is -1, minus y1, which is 4, quantity squared. Okay, so we got square root of, well, 2 minus -3 is 2 plus 3, or 5 squared. Plus we've got -1 minus 4 is -5. That's got to be squared. So we got square root of 25 plus 25, or square root of 50. Well, square root of 50 is an exact answer. If you put square root of 50 in your calculator, you're going to get a nice little decimal. So let's keep it exact, but let's take square root of 50 and simplify it. You can think about the fact that 50 is the same thing as 25 times 2, and 25 is a perfect square. Square root of 25 is 5 times square root of 2. So the distance between those 2 points is 5 square roots of 2 units. That's the exact answer. And if you put it in your calculator, you'd get that it's approximately 7.071 units. But we didn't ask for approximation or estimate. We're going to ask for exact right now, so we'll leave it as 5 square roots of 2 units. So that's how far apart these two are. And if you look at the formula, like you look at point P, its x value is here, and point Q's x value is there. You got 1, 2, 3, 4, 5 units between them. So you got 5 units squared. And then if you look at the y values, P's y value is up here, Q's y value is down here. You got 1, 2, 3, 4, 5 units between them. So you end up with another 5 squared, which is 25 also. So you can look at your units and count them, and that would tell you what you're squaring in your formula there. And that's the distance formula. You will be using that in some application problems down the road. Then one more formula, and that'll actually finish up 1.1 for us, is the midpoint formula. For a line segment with endpoints x1, y1, and x2, y2, we can find the middle point, the point exactly halfway between those two, by examining the average of the x coordinates and the average of the y coordinates. Well, average is a measure of central tendency. You're trying to figure out where the center is or where the halfway point is. So it makes sense that if you want to find the halfway point, you do averages. So you have x1 and x2, two x values, find their average, you add them up, divide by 2. Two y values, add them up, divide by 2. And there you go. Okay, so let's go back to the problem we were just doing, where we had point P at -3, 4, and we had point Q at 2, -1. Let's say we want to find the midpoint. Okay, formula says take -3 plus 2, divide by 2, and take 4 plus -1 and divide by 2. So we end up with -1/2, 3 halves. And that's the midpoint. That's the point halfway between the two. Let's quickly sketch them again. -3, 4, put you right here. 2, -1, put you right here. So that's P, that's Q. And then -1/2, 3 halves, put you right here. That's the halfway point between P and Q. Now, not all of your problems are going to be find the halfway point. Sometimes you'll be given a point and the midpoint and have to find the other endpoint. Let's say you're given P is at coordinate 7, -4. And let's say you're given that the midpoint is at 8, 5. And it's up to you to find Q. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 7, -4 is right here. That's P. M is 8, 5. Just here. And so somewhere up here is Q. You have to figure out where it is. Well, if you look at your X values, your X values from point P to your midpoint go from 7 to 8. It increases by 1. So to get to Q, you got to go the same distance past the midpoint. So this is P, this is the midpoint, this is going to be Q. Then you just add one more and you get 9. And the y values go from -4 to 5. Well, that's 9 units. So go an additional 9 units and you get to 14. Oops, it's +9. I should, that negative sign there throwing me off. Sorry. So 9 comma 14. So if you go to 9 and then up to 14, that'll be way up here where Q is. Well, if you think about it too, you're thinking about 7 plus what divided by 2 would equal 8, and -4 plus what divided by 2 would equal 5. Because you find, midpoint is the averages. It's the x's added up divided by 2, and the y's added up divided by 2. Well, 7 plus what divided by 2 is 8. So 7 plus what equals 16. So what would have to be 9. -4 plus what divided by 2 is 5. So -4 plus what would have to equal 10. So the what would have to equal 14. So there's different ways. I call the first way I did it kind of a more common sense, rationalize it kind of way. And then the second way is more algebraic. But yeah, both of them work. And you might have a third way that you reason through it, and that's okay too. But there you go. So that's a little bit about all three: the Pythagorean theorem, your distance formula, and your midpoint formula. Definitely commit all those to memory and know how to use them. Thank you for joining us.